Good morning. These are practice questions that were sent out the other day. I'm going to provide answers if you require them. We're working with vector equations and parametric equations. In the first question, not terribly hard, determine the vector and parametric equations of a line passing through this point with a direction vector of this. If I were to make a sketch, 1, 4, this is the slope. Rise over run, rise and run. -3, up 3. I would get a line looking something like this. I could do the slope triangle all the way along. For a vector equation, from the last lesson, we know this is the basic equation. It can be modified into and in our case, we're given a point, 1, 4, and we're given the slope. There's the vector equation. Parametric, x equals 1 minus 3t, y equals 4 plus 3t. X equals 1 minus 3t, y equals 4 plus 3t. We're in two space, two vector equations. Two parametric equations. Now, using these, I want to find out some points that would be on the line, other than 1, 4. So let's make up some headings, t, and the two vector parametric equations. And here would be the points that we do get. I arbitrarily picked 2. So I would get x equals 1 minus 3 times 2, 5. I would get y equals 4 plus 3 times 2, 10. -5, that was a negative, I'm sorry. 10. If I picked 3, I would get -8, 13. If I picked -2, I would get 7 and -2. Then I picked 7, -20, 25. In fact, I could pick anything for t and I would get a bunch of points. Now I'm assuming they're all on the same line. Let's check that. Let's check it by finding slope. I'll pick the first 2 points. In which case I will get 13 minus 10 over -8 minus a -5. I will get 3 over -3, which is -1. If I pick the last 2 points, I could pick any one of them. I'd get 25 minus a -2 over -20 minus 7. I would get 27 over -27, -1. This is not a real surprise because from the initial vector equation, my slope is -3, 3, which is -1. Flip side. using the same equation I had on the other side. They want to know if these 2 points are on that line. Again, there are an infinite number of points on the line, but not every point is on the line. I'm going to use the two parametric equations. X equals 1 minus 3t, y equals 4 plus 3t. If I pick the first point, Q, negative 21, 23. If I let x be negative 21, bring it across, negative 22 over 3 equals t. If I now let y be 23, I would get 23 equals 4 plus 3t. 19 divided by 3 equals t. These are not equal. T equals negative 22 over 3, t equals 19. So it's not on the line. Okay, let's try the other point. R, negative 29, 34. 29 equals 1 minus 3t. Bring it across. That's a negative 29. I get negative 30 over 3 equals t. Negative 10 equals, divided by positive 10. 34 equals 4 plus 3t. 30 divided by 3 equals t. T equals 10. Both t's are the same. Point is on line. One more question in this part. Determine the vector and parametric equations for these 2 points. I'm going to make a diagram. There is F, 6, 11. There is E, negative 1, 5. We have done this before. I'm going to make vector diagrams, position vectors. Vector OE, vector OF, vector EF. We've done this before. OE plus EF should equal OF. From there to there, there to there. Okay. That means EF equals OF minus OE. 611 minus negative 1, 5. 7, 6. I could have gone the other way. My answer could have been negative 7, negative 6. It doesn't matter. But this is good. Now, this is the components of that vector. So this is the same thing as saying this. This could be a position vector. All right. Now, a vector equation, xo, yo plus t, m. Well, as it is, I have 2 points. I can use either one. So I'm going to get negative 1, 5 plus t, 7, 6. Or I could have just as easily have used the other one. I could have responded with either one of these 2 vector equations. They've asked for the parametrics, so I would get x equals negative 1 plus 7t, y equals 5 plus 6t. This one, x equals 6 plus 7t, y equals 11 plus 6t. Doesn't matter which one I use, I will get points on that line. This ends part one of this.